Hi everyone, my name is Vicente Miñana and I am going to present you the speech that is titled The Validity of Measurement Instruments, Experiences in Physical Education. This work is framed within the symposium entitled Development and Evaluation of Instruments for Measuring Learning in Physical Education, which has been organized by the Back Health Education Research Group led by Dr. Monfort Pañego. We are a group of teachers from the Teacher Training Faculty of the University of Valencia. A lack of consensus exists about terminology and definitions of measurement properties across the different fields that contribute to education measurement. For example, in the literature, many different terms from the same measurement property, reliability, are used interchangeably, such as reproducibility, reliability, repeatability, agreement, precision, variability, consistency, and stability. At the same time, the term agreement is also used to indicate another measurement property, that is, measurement error. Different uses of the terminology can lead to confusion about which measurement property is assessed. Differences in definitions may lead to confusion about which concept the measurement property represents and how it should be assessed. Regarding the back health education research line in children and adolescents population, it has been an increasing number of studies and evidences during the last 20 years. Numerous interventions programs and randomized control trials have been developed in order to improve the back health in students through the knowledge, postural habits or behaviors, and muscle endurance. However, most of the studies used heterogeneous instruments and self-developed tools with poor psychometric analysis. For more robust comparisons of the studies, some authors have validated some knowledge instruments such as the presented in that layout. To use a homogeneous set of instruments could compare and facilitate the analysis of educational research to apply in physical education lessons and school contexts. For these reasons, the COSMIN study aimed to clarify and standardize terminology and definitions of measurement properties by reaching consensus among a group of experts. In addition, was developed a taxonomy of relationships of relevant measurement properties for evaluating instruments. The consensus that COSMIN's initiative reached on these issues is needed to find more uniformity in the use of terminology, definitions, and subsequently the design, requirements, and statistical methods. Results of studies on measurement properties are then better comparable. Moreover, consensus on these issues can lead to more understanding about what important measurement properties of measurement instruments are and how they should be investigated. The psychometric measurement is the field of the research that focuses on the development and validation of assessment tools to measure abstract variables. For that, we need to assess and to measure, and we need to know the difference between these two concepts. So the first one, the assessment, refers to the process of collecting, synthesizing, and interpreting information, including data from tests as well as from observations. Regarding measurement, is the process of qualifying or scoring assessment information. The researcher has to carefully choose the adequate and accurate tool in order to ensure the quality of the results. It is necessary to know the instruments in details, items, domains, assessment forms, and especially measurement properties before using them. The quality of the information provided by the instruments depends, at least partly, on their psychometric properties. Before being considered suitable, the instruments must offer accurate, valid, and interpretable data for the population's health or education assessment. Moreover, the measures are supported to provide scientifically robust results. The performance of results of these measures comes from the reliability and validity of instruments. Despite disagreements in some points, researchers are unanimous in considering the reliability and validity as the main instruments' measurement properties. For that reasons, the key indicators of the quality of a measuring instrument are the reliability and the validity of the measures. Here in the figure, we find two definitions for each psychometric measurement. Regarding reliability, it is defined as the extent to which the outcomes are consistent when the experiment is repeated more than once. In other words, is the degree to which the measurement is free from measurement error. According validity is the extent to which the instruments that are used in the experiment measure exactly what you want them to measure. In other words, is the degree to which an instrument measures the constructs it purports to measure. The next figure shows the possible relations between reliability and validity. In the first target, the shots were reliable, hitting the same point. However, none has hit the center of the target, not being considered valid. The second target may be considered valid, although not reliable, because the points hit are not located in a specific place, but were spread throughout the whole target. The third target did not present reliability or validity, because they hit spread points only on the superior part of the target. The fourth target represents the perfect example of reliability and validity. The shots hit the place they were supposed to and were consistent right in the target center. Such relations can also be applied to assess the properties of instruments' measurements. Researchers affirm that an instrument that is not reliable cannot be valid. However, a reliable instrument can sometimes be invalid. A taxonomy of relationships among measurement properties provides a complete picture of the relevant measurement properties when assessing the quality of health or education outcomes. A taxonomy is a classification containing domains and subcategories. In our taxonomy, the measurement properties and aspects of measurement properties are the subcategories. In the next table, number 1, find in the Cosmin study, it's possible to see that they reached a consensus on the large majority of issues. This table presents the percentage of the panel members who agreed on position in the taxonomy, terminology, and definitions of the measurement properties. The taxonomy of the measurement properties is presented in the next figure. In assessing the quality of an instrument, we distinguish between 3 quality domains. They are reliability, validity, and responsiveness. Each domain contains one or more subcategories, that is, measurement properties or aspects of measurement properties. The first one is the domain of reliability, contains 3 measurement properties that they are internal consistency, reliability, and measurement error. The second domain could be the domain of responsiveness, containing only one measurement property, which is also called responsiveness. The third and last domain could be the validity, that also contains three measurement properties: content validity, construct validity, and criterion validity. As we said, some of measurement properties contain one or more aspects that were defined separately. For example, content validity includes phase validity, and construct validity includes structural validity, hypothesis testing, and cross-cultural validity. In the present layout, we can find the definitions reached by consensus by the group of experts of the Cosmin study. Here appears the validity domain, composed by three subcategories, or psychometric measurement, and their aspects. For example, we can see that the content validity is composed by an aspect, and is the phase validity, and it's the degree to which the items of an instrument indeed look as though they are an adequate reflection of the construct to be measured. On the other side, we can see the criterion validity in the last place, but before we find the subcategory of construct validity, composed by the structural validity, hypothesis testing, and cross-cultural validity. Here you can find the definitions, as we said. To select or find an instrument, researchers have several ways to find it. In the first place, they can find an existing instrument or standardized one. For example, they can find in the back health education research line the instruments that we show at the beginning. They are validated and reliable, and they are proof tests. The second way, a researcher could self-develop an instrument for their own. And the last one, it could be to record naturally occurring events or already available data. Don't forget that before developing a new test or measure, an investigator should identify existing instruments that measure the construct of interest. Using an existing instrument that has substantial evidence of reliability and validity in a variety of populations is more cost-effective than starting from scratch to develop and validate an instrument. In selecting an instrument, the following questions should be addressed. The first one says, do instruments already exist that measure a construct the same or very similar to the one you wish to measure? Before you begin searching for instruments, you must have a clearly defined construct or concept that you wish to measure, along with an operational definition and some evidence that the construct can be measured as defined. In the second place, how well do the constructs in the instruments you have identified match the construct you have conceptually defined for your study? In evaluating whether there is congruence, do not rely on the title of the measure or on the operational definition of the construct that appears in a research article or the description of the variables in a secondary database, such as a medical record or administrative claims database. Real understanding of the measure usually requires an examination of the actual items or questions and the way data were generated or documented. In the third part, is the evidence of reliability and validity well established? Has the measure been evaluated using various types of reliability estimates and varied strategies for establishing validity? Has it been validated in a population similar to the one you will be studying? In the fourth place, in previous research, was there variability in scores with no floor ceiling effects? Did previous studies have a large amount of missing data, either on the measure itself or on items within the measure. In the 5, if the measure it is to be used to evaluate health outcomes, effects of interventions or change over time, are the studies that establish the instrument's responsiveness to change in the construct of interest. Obviously, it is important that change in measurement be due to change in the construct rather than in the instability of the scores. In addition, it would be helpful if there were data on how much change in scores would be required to be considered clinically meaningful or educationally meaningful. 6. Is the instrument in the public domain? If not, it will be necessary to obtain permission from the author for its use. Even though an instrument is published in the scientific literature, this does not automatically mean that it is in the public domain, and permission from the author and publisher may be required. If it is a copyright instrument, you may have to pay a fee to purchase or use the instrument. Some instruments might also require additional fees for scoring. Question number 7. How expensive is it to use the instrument? An email questionnaire costs less to administer than to telephone or face-to-face interviews. Using electronic data is usually less costly and time-consuming than conducting medical record reviews. However, electronic data might not contain information that is available on patient charts, so a thorough understanding of the limitations of the data available as well as the requirements of measurement for your study is important. Question number 8. If the instrument is administered by an interviewer or if the measures require use of judges or experts, how much expertise or specific training is required to administer the instrument? And the last one, the 9. Will the instrument be accessible to subjects? Does the test require invasive procedures? Is the reading level appropriate? Is the respondent's burden, including complexity of questions and time needed to complete the instrument, unlikely to affect response rates or the quality of responses? Keep in mind that reliability and validity evidence from established instruments is applicable only if you use the instrument in the same form and follow the same administration procedures as used in the validation study. On the other side, modifications of validated instruments might require permission from developers and also require validating the modified instrument as if it were a new instrument. To facilitate the work to researchers in selecting an existing instruments, we can find several locations to obtain information and reviews about available tests. For example, we have databases like physical activity assessment resources, PROMIS, or test collections where we can reach validated and standardized instruments. On the other side, we have professional journals where we could find validated and reliable and publicated tests. And the last option could be the guidelines, for example, like COSMIN one. Please, in the next layout, you could find the protocol that resumes all the explanation of this presentation. Using only 4 steps, you will be able to select the appropriate and accurate tool. Finally, for the purposes of drawing robust conclusions about postural interventions in primary or secondary school settings and even in physical education lessons, researchers should adopt a uniform suite of assessment instruments in order to measure the various constructs in the investigations related to back health educations, as could be back pain prevalence, knowledge, postural habits, behaviors, or muscles endurance. If researchers agree to use a singular set of postural metrics, it might provide clearer evidence about which treatments work best and why. Thank you very much for your attention. We hope you liked the presentation.